उच्च शिक्षा विभाग मध्य प्रदेश शासन द्वारा आयोजित ऑनलाइन क्लासेस कार्यक्रम में आप सभी का स्वागत है। आज हम एमएससी फाइनल फिजिक्स सेमेस्टर थर्ड के पेपर थर्ड डिजिटल इलेक्ट्रॉनिक्स की यूनिट 1 नंबर सिस्टम्स पर चर्चा करेंगे। माई सेल्फ डॉक्टर आलोक कुमार रस्तोगी, Professor of Physics, Institute for Excellence in Higher Education, Bhopal. So today's our topic is number systems, and our objectives are to understand the concept of number system, to know about the decimal number system, binary number system, octal number system, and hexadecimal number system. So first we will see what is a number system. If you want to define it, a number system defines a set of values used to represent quantity, and in computer architecture supports the following number systems, and these number systems are decimal number system, binary number system, octal number system, and hexadecimal number system. Now, the different number systems are having different base or radix. First, we talk about the decimal number system. In decimal number system, base or radix is 10 because decimal number system is having 10 distinct symbols. We will discuss about them in further slides. Binary number system, it is having radix or base 2 because it is having two distinct symbols, and the third one is the octal number system. In this number system, the base or radix is 8 because it is having 8 distinct symbols, and the finally the hexadecimal number system, which is having base or radix 16 because it is having 16 distinct symbols. So we will see the what is actually number system is. If we want to define a number system, we can define it by in this way that if in any number system there is an ordered set of symbols known as digits. So we are having a number here, 5678.123 in decimal number. So what I want to say that in any number system, it may be decimal, it may be binary, it may be octal, or it may be hexadecimal. So what I want to say that in any number system, there is an ordered set of symbols known as digit, and this collection of digits is known as a number, which is having two parts. The first part is known as the integer part, and the second part is known as the fractional part. And these two parts, integer part and fractional part, are set apart by the radix point, or this is known in decimal number system, it is known as decimal point. In binary number system, it is known as binary point, and so on. So we can say that in any number system, there is an ordered set of symbols known as digit, and the collection of digits is known as number, which is having two parts. One part is known as integer portion, the other portion is known as the fractional portion, and these two portions are set apart by the radix point. So we have seen the common number systems, decimal, binary, octal, and hexadecimal. In decimal number system, base is 10 because it is having 10 distinct symbols from 0 to 9, and it is used by computers. No, it is not used by the computers. It is used in high level languages, and binary number system, which is having two distinct symbols. That is why the base of binary number system is 2. And it is used by human beings? No, it is used by the computers, of course, yes, because machine language is used by binary number system. Then the octal number system, whose base is 8, and it is having 8 distinct symbols from 0 to 7. And finally the hexadecimal number system, whose base is 16, and its distinct symbols are 0, 1 to 9, and capital A, capital B, capital C, capital D, capital E, and capital. So 16 distinct symbols are used in hexadecimal number system, and it is used by computers, of course, yes, because in assembly language programming of microprocessor, these hexadecimal number systems are frequently. So first we will know about the decimal number system. What is the uh, formation of decimal number system we want to see. In decimal number system, it is derived from Latin root decem, which means 10, and the base of the decimal number system is 10 because it is having 10 distinct symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the symbols in this system are often referred to as a decimal digits, or we call them digits. In decimal number system, there are 10 distinct symbols, and since the counting in decimal involves 10 symbols, that is why its reduced point is 10. The most important thing is that it is a positional weighted system. What is the meaning of positional weighted system? Each position is having its own weight, and I'll show you it by the example in the next slide. In this system, any number, it may be integer, it may be fractional, it may be mixed, of any magnitude can be represented to use these symbols, and these numbers are also called, these symbols are also called digits. Now, this is the structure of decimal number system. I have taken an example of decimal number system, and I had given the positional weights 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, and so on the uh, integer side, and the fractional side 10 to the power minus 1, 10 to the power minus 4, 2, and so on the fractional side. So how we can measure, because there are two most important terms, MSD and LSD, that is most significant bit. It means that the leftmost digit in any number representation which has the greatest positional weight is known as the most significant bit, and similarly the rightmost digit in any number representation which has the least positional weight is known as the least significant bit. I will show you in the example which one is the. Here I have taken a number, you see 1214. In this number, 4 is the LSD, that is least significant digit, and uh, 1 is known as the most significant digit. And when this number is represented in decimal number system, what we have to do at the unit portion, 4 is multiplied by 10 to the power 1 because it is positional weighted, and 1 is multiplied by 10 to the power 1, 2 is multiplied by 10 to the power 2, and 1 is multiplied by 10 to the power 3, and when we sum up them, we will get the actual number. Similarly, I have taken another example, 1897, where 7 is at the LSD position and 1 is at the MSD position. And when we give the positional values to these numbers, and they are multiplied by their positional values, positional weight, and when we add them, we will get the result. The third example I have taken, in which I have taken a mixed number in which uh, integer portion and fractional portion both are present with the radix point, and you can see when we had given them the positional weight, uh, see in the fractional part, 5 is multiplied by 10 to the power minus 1 plus 4 into 10 to the power minus 2, and similarly we had given weight in positional weight in integer portion, and when we add them we will get the final number. The next number system is binary number system. As we know that there are only two distinct symbols, 0 and 1. So this binary number system is having base 2. Why we call it binary? Because the word binary is derived from the Latin root bini, which means 2, and the system the base is 2, and here these are the two distinct symbols as 0 and 1, and these two symbols are known as binary digit, or we call it bit as well. In binary number system, again a positional weighted system, it contains two unique symbols 0 and 1, and because there are only two distinct symbols, that is why its radix point, its radix or base is 2. While the binary digit is called bit, this is what we have seen in binary number system. There are two distinct symbols 0 and 1, and the binary points separate the integer and fractional part. So similarly, in the binary number system, we are seeing the structure of binary number. Here we can see that this is the binary number and these are the positional weights. This is the position of binary point. The here we can see that this one is known as the LSB, that is least significant bit, and this one represents the most significant bit. I will show you this thing in example. I have taken a number 1011 radix point 01 binary number which has to be converted into equivalent decimal number so that you can understand how positional weight works. I have taken a binary number 1011 radix point 01, and I had given then its positional weights here 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and in the fractional part if we goes 2 to the power minus 1, 2 to the power minus 2, and so on. When we multiplied by this binary number with their positional weight, and when we add them we get the decimal conversion of this binary number. So here the conversion is comes out to be 11.25 of decimal. It means 1011.01 is equivalent to 11.25 of decimal. So if we see the table of binary number system in which I have shown the comparison of decimal and binary number from 0 to 15 I have taken, and these four digits, or we call them bits, these bits when they come in together they are also known as nibble. I will tell you there are some related terms with binary number. The first one is the bit. As we know that bit is a binary digit, either it will be a 0 or 1, and then the next important term which is frequently used is nibble. Nibble means a string of 4 bits or the combination of 4 binary bits. So here I have shown the 4 examples of nibble. Then the next term comes, which is known as byte. Byte means the string of 8 bits or the combination of 8 binary bits. The number of the distinct values represented by the byte is 256, ranging from 00000000 to 11111111. So in this range there are 256 combinations are available of 0 and 1s, and when we write a byte which is consist of 2 nibbles, obviously because nibble is having a combination of 4 bits, so 2 nibbles are used here. The first one from right to left, first one is known as the lower order nibble and the other one is known as the higher order nibble. That is why this B7 is represented by MSB and B0 is represented by LSB, that is least significant bit. Next, after the byte, there is a word. The word is a combination of 16 binary bits and it consists of 2 bytes. So here we are having lower byte and here we are having the higher order byte, or we can say that there are 4 nibbles um, which frame the word, and here the B15 is most significant bit and the B0 is known as the least significant bit. So I hope you can understand what is bit, what is byte, what is nibble and what is word. Another thing is that double word is also there. A double word is exactly what its name implies. The two words, the combination of 32 binary bits is known as the double word. This is also used in computer systems. We know uh, our system is 64 bit or 32 bit or 16 bit. So this is the thing by which we can understand, yeah, our computer system is having how many bits, and if it is having 32 bits it can be say it is a double word. If it is 64, then how many bytes are there? There 8 bytes are there, and so on. In the octal number system, the word octal is derived from the Latin root octo, which is means 8, and its base is 8, and its distinct symbols are 0, 1, 2, 3, 4, 5, 6, and 7. And in octal number system, it is also a positional weighted system, and its unique symbols are 0 to 7, means its radix point is 8. Uh, the largest value of the digit in octal number system is 7. Obviously, it starts from 0 to 7. The 7 is the maximum value. It means in octal number system, the higher, if the number is higher than 7, will not be 8. Instead of 8, it will be 10. And then, so if we count the numbers from 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7, then 1, 0, 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, then 2, 0, and so on. Now here you see the structure of octal number system. I had given the octal number here and their positional weights are beneath them, and this point represents the radix point in octal number, and these are the positional weights. The most important thing in octal number system is that as we know that 8 is equal to 2 to the power 3, binary number is having base 2, it means we can say that Each digit of octal number system can be replaced by 3 bits of binary. So whenever we are going to convert octal number into binary number, so simply what we have to do, we have to replace each bit of octal number by the 3 bits of binary. Or we can say that the octal number is thus 1/3 length of the corresponding binary number. Now, you see one example by which we can understand how the positional weight works in octal number system. I have taken an example 365 uh, radix 0.24 of octal number, and we want to see the equivalent number in decimal. So what we have to do, simply we have to place their positional weights, because in octal number system base is 8. So instead of uh, 10 in decimal number, instead of 2 in binary number, we are putting here 8, because the positional weight in octal number system or base in octal number system is 8. We have put on them, and then what we have to do, we have to multiply this number with the positional weight and add them. We will finally get the result, and we can say that the octal number 365 radix 0.24 is equivalent to the 245 decimal point 3125 of decimal number. In octal number system, if we see the table, I have given the comparison of conversion of octal number to binary and binary to octal. So you can see I have taken some values here from 0 to 13. They are corresponding values of binary. Obviously, they are in nibble. And then here you see 0 to 7, and then the next equivalent is 10, and then 11, 12, 13, 14, 15, and so on. The last number system, which is a hexadecimal number system, it is a very, very important number system for computers, because the assembly language programming is done in hexadecimal number system, and definitely it is faster than the binary number system. So what is hexadecimal number system? Hexadecimal number system is a positional weighted system. It contains 16 unique symbols, which are 0 to F. It means after 9 we have taken capital A, capital B, capital C, capital D, capital E, capital F. What does it mean? This A is equivalent to 10 of decimal number. B is equivalent to the 11 of the decimal number. C is equivalent to the 12 of the decimal number, and so on, and they goes up to 15, that F is equal to 15 and E is equal to 14. So in this way their positional values are there. Now see the hexadecimal number system. Here we have shown the structure. In this structure we have shown a hex number and their positional weights. This point represents the radix point which separate the integer and fractional part in the hexadecimal number system, and their positional weights have shown in this diagram: 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3, and the fractional weight 16 to the power minus 1, 16 to the power minus 2, and so on. In hexadecimal number system, the most important thing is that you see this 16 is equal to 2 to the power 4. So what we can understand, the base 2 is having binary number. So each digit of hexadecimal number system can be replaced by 4 bits of binary. It means whenever we are going to convert a hexadecimal number system into binary number system, simply what we have to do, we have to replace each digit of hexadecimal number system by the 4 bits of binary. It means hex number is having 1/4 of the length of the corresponding binary number. The hex system is particularly useful for human communication with computer. Now, see the example of hexadecimal number system, how this number is converted uh, into decimal number. We have given the positional weights 16 to the power 0 to 6, 16 to the power 1 to 2, 16 to the power 2 to 8, and 16 to the power 3 to 5. Now what we have to do? We have to multiply this hexadecimal number with its positional weight and add them. We will get the final result in terms of decimal number. So 5826 of hexadecimal numbers is equal to 22566 of decimal number. Now hexadecimal number system can be represented by a table in which I have shown decimal number, binary number, and hexadecimal number. Decimal numbers from 0 to 7 and 8 to 15. Their corresponding binary numbers and their corresponding hexadecimal number system. So after 15, the 16 will be 16 of decimal number will be equal to 10 of hex number, and so on. Then it will go ahead. Now, finally, I have shown a table of comparison of decimal, binary, octal, and hexadecimal number system where the conversion of decimal number from 0 to 15 into binary, into octal, into hex. So I want to recap today's lecture. Today we have seen the definition of number system, and then after that we understand the decimal number system whose base is 10, and because it is having 10 distinct symbols from 0 to 9. Then we came to know about the binary number system in which base is 2. Why base is 2? Because it is having two distinct symbols 0 and 1. And after that we learned about the octal number system, which is having base 8, and it is having uh, 0 to 7 distinct symbols. And finally we learned about the hexadecimal number system. In hexadecimal number system there are 16 distinct symbols from 0 to 9, and capital A, capital B, capital C, capital D, capital E, and capital F. And this F is having the highest value in unit. So after that I want to tell you about the reference books. You can refer these books. Digital Circuits and Digital Design by the Salivahan, Vikas Publishing House, it's a good book. And Digital Fundamentals by Basav Raj, Vikas Publishing House again. And then Digital Principles and Applications by A.P. Malvino and D.P. Leach, McGraw-Hill International Edition. It is excellent book of digital electronics. And then Digital Computer Electronics by Malvino and Brown. It is from the TMH publication. I have shown 4 reference books. There are several books are available in the market on digital electronics. Now, this is the time to assess yourself, and you have to solve the some little questions Questions of MCQ. My first question is, in binary number system, a digit ranges from. I had given four options here. The first option is 0 to 9, the second option is 0 to 1, the third option is 0 to 15, and the fourth option is 0 to 7. As we know very well that in binary number system, the radix or base is 2. There are only two distinct symbols. So in binary number system, the digit ranges from 0 to 1 only. So the result of this MCQ is obviously B. Now the next one I have taken the largest two digits hexadecimal number is, I remind you once again, the largest two digit hexadecimal number. I have given four options A, F, E. On B, option B, F, D. Option C, F, F, and option D is E, F. So what will be your answer? Because we know that in hexadecimal number system, the highest digit is F. It goes from 0 to 9, then capital A, capital B, capital C, capital D, capital E, capital F. F is the highest, the largest value. So in two digit, the FF will be the, obviously the answer of this question is C. Now the third question, as any signed negative binary number is recognized by its, you have to tell whether it is MSB or LSB or byte or nibble. Let us see what is nibble. Nibble is a string of or combination of four binary digits. Byte is a string of 8 bits or combination of 8 binary digits. LSB means the least significant bit and MSB means the most significant. So what is the answer? Obviously the answer is A, because what we have asked, any signed negative binary number is recognized by its MSB. Only by MSB you can understand it. Well, the next question is for you. You have to solve it. The representation of octal number 532 radix point 2 in decimal number is, you have to tell the answer, which is in these four multiple choices. What you have to do is you have to give the positional values, positional weight, and multiplied by the positional weight to the every digit and add them. You will get your result, and your result is here, option A. The last question, where we have to convert a hexadecimal number 1E2 of hexadecimal into the decimal number system. So its options are 480, 483, 482, 484. Similarly, you have to do your job here. Your answer is 482. Thank you very much.